Hi everyone, I'm Sean from Crafted Elements, and in this video we're going to be looking at the Crafted Elements Small Trim Router Sled Kit. Now this video is going to be applicable, of course, if you've purchased the 36 by 32 trim router kit from us, but it's also going to be applicable if you've purchased one of our larger router sleds but are opting to use the trim router base because you want to use a trim router with that larger kit. So the first thing we're going to do is talk about what's in this video. We're going to be looking at the components themselves, what should be included. We're going to build it in real time so you can see how it's built. We're going to address any sort of issues or common technical problems that you might run into while assembling this thing, so it'll be easier to do when you actually start your assembly. We're also going to be doing some actual samples. We're going to put the router sled through its paces, see what it can do, and I'm going to give you some tips and tricks in terms of hold down and troubleshooting, what bits to select and all that. So if you've purchased one of these kits, I guarantee watching this video is going to save you time and frustration. If you watch it to the end, you'll kind of be an expert by the time you want to put this thing together and use it. All right, so we're going to get started by talking about the components that are included in the Crafted Elements Small Router Sled Kit. You have our trim router base, which is compatible with most of the popular trim routers on the market. You've got the crossbar brackets. You've got 4 closed linear bearings and 4 open linear bearings. You've got 4 N shaft mounts, and then you've got 4 C clamp stops. Over here you have the screws and hardware to connect it all together. There should be 28 of the 20mm long M6 screws and 4 of the 30mm long M6 screws. You'll also see 4 of the M4, which are 4mm, 20mm long screws to attach your router to the router base plate. Over here you've got 2 phenolic handles and then the screws to attach them to the router base plate as well. Starting with the actual main hardware, you've got 32-inch long crossbars, or 32-inch long shafts, if you will, and you've got 36-inch long rails to actually mount to your workbench or tabletop. So now that we've looked at what the Crafted Elements Small Router Sled Kit does include, let's talk about the things it does not include that you are obviously going to need to make everything work. Might be obvious, but you're going to need a tabletop, a flat workbench, a flat surface to mount all the components to. That is not included in the kit. Second thing that may also be obvious is a router, specifically a trim router. This is a trim router kit designed for these smaller kind of palm routers that you'll find on the market. This trim router base has pre-drilled holes for companies like DeWalt, Milwaukee, Bosch, Makita, Ryobi, Rigid, and probably a couple more. Now, if your router is not listed in the compatibility chart, don't fret. As long as it is a standard palm router, it doesn't matter if it's a plug-in corded router or a cordless battery router. You can line it up with our base, mark your own holes, and pre-drill them in the acrylic. We just provide, of course, the pre-drilled holes for most popular routers to get you up and going quicker. The next thing you're going to need is a slab leveling bit, or a spoil board bit, if you will. In your case of your trim routers, you do not want to get a spoil board bit that's greater than 1.5 inches in diameter. With our bigger router systems, our bigger router sleds that use larger full-size routers, you can use 2.5 or 3-inch diameter bits. But with the trim routers, they're generally a horsepower, maybe a horsepower and a quarter, and they just don't have the power to move a very big diameter bit and level the wood without bogging down and messing up your project. So 1.25 inches or 1.5 inches router bit is pretty much the best choice for you. All right, guys, so we're ready to start the assembly of the Crafted Elements Small Router Sled Kit. I'm going to go ahead and clear off my table area so we can get started. So as our router sled kit is a 36 by 32 inch kit, I've gone ahead and made a 36 by 32 inch platform to mount it to. Now, of course, you don't need to make a dedicated platform for this. You can use your existing workbench or shop bench or a spare area of your shop as a flat surface. The key is that you want a flat surface. You do not want curves, warps, or anything funky. It needs to be as flat as possible, because if it's not flat as possible, the pieces that you're milling in here are not going to be flat as possible, and that's going to be reflected when you actually use your slab leveler. So at the end of this video, I actually show how I built this. I didn't want to put it at the beginning because it is kind of a boring process. It is something very basic to build, but in case you want to see how I built this, including all the supports that are underneath and why I put them there, stay to the end of the video and you can see the process to building this platform. So the first thing we're going to do is mount our rails. Now the key is that these do not include any screws, because depending on what you're attaching it to, you might need short screws, you might need long screws, so you don't include any screws in the kit, but they are obviously pre-drilled holes. In this case, this is 3/4 inch plywood, so I'm just going to use some 1/2 inch or 3/4 inch screws. And I'm going to start by mounting my first rail. Now I know that this is already square and flush. It is 32 inches in length across. But when you mount these, you're going to want to get your measuring tape out to make sure the distance between the end of the mount and the inside of this mount is the same all the way through. In other words, you don't want one rail like this and the other rail like this. You want to have them completely parallel to each other. So I'm going to go ahead and grab my drill and I'm going to get this mounted really quick. So we want to make sure we measure the distance between each of the ends to make sure it's the same, to make sure everything is parallel. So given the width of this board and the width of our rails, we should have 28.5 inches between the rail mounts throughout, 28.5 inches between them. So we've got our rails mounted to our platform or workbench or our removable table in this case. I'm going to go ahead and put this to the side for now because I'm going to assemble the actual router base and router mount first. So we're going to go ahead and grab our router plate. Now this router plate, very, very cool. You'll see that it has a variety of pre-drilled holes with some letters next to them. Those letters represent the brand of the router. So I've got MK for Makita, B for Bosch, so on and so on. Now you'll notice that these holes are not countersunk. If you would like to countersink them, you can do so with a countersink, but really it doesn't serve much of a benefit because when you actually mount the linear bearings to these, you're using with these M6 screws. Those screws are roughly 1/4 inch off the surface of this anyway. So there's not really much of a point to recessing those holes unless you're an absolute stickler for getting the absolute most capability out of this. But you also have to remember that your bit that you're going to use is also going to be sitting ideally below the or above the acrylic towards your piece that you're working on, and that bit itself is 3/8 to 1/2 inch thick. So that's the reason why you don't really need to worry about countersinking this stuff. The one thing that we do have pre-countersunk is the holes for the phenolic handles because they are kind of beefy screws and they're not a flat hex head like the other screws. So we definitely want to have those countersunk, mostly for aesthetics, to be honest with you. The first thing I'm actually going to mount to this is our linear bearings. So that's what we're going to start with. I'm going to go ahead and change the camera angle so you can get a better view of what I'm actually doing. Now the bearings that we're going to mount to this are the closed linear bearings as opposed to the open linear bearings that ride on the rail system. Now the top of this base plate is the side without the etching, the side that does not have the letters and the countersunk holes for the handles. So we're going to go ahead and mount these to the top. So move them to the top, flip them over to the side that actually does have the etching, and you're going to grab 4 20 mil, so 4 of the short screws per bearing. Now, these do come, of course, with an Allen key to put these screws in, but I'm going to cheat and use this just because it's more ergonomic. So you can either use the Allen key that's in the kit, or you can grab your T key or your T handle key to put these in. Now, one tip, very important, do not fully tighten these things. You want to leave them a little bit loose because once you actually mount these to the rails and slide your rails in there, if these are off at all, a millimeter this way or this way, it's not going to be as frictionless or as smooth sliding on those. So what we're going to do is we're going to kind of loosely mount these. We're going to stick our rails in there, slide it back and forth, which is going to essentially align the bearings for us, and then we're going to tighten them down. All right, bearings are in place, loosely fitting. I'm going to grab one of our crossbars or our shafts. I'm going to slide it in here and in here and make sure that it goes nice and smooth. Now, doing that a couple of times is going to make sure that those bearings are perfectly aligned. With those shafts in place inside, we can go ahead and fully tighten these up. All right, we've tightened up all those screws. We can slide those shafts right back out, and then we can actually go ahead and mount our router base plate to our router. Now this is a standard DeWalt corded router. I've already taken the plastic base plate off that comes with this. So generally when you get a router, it will have an existing base plate. You want to take that off. Now you may want to save those screws. In general, you probably won't be able to use those screws with this because most of those base plates are around 1/4 inch and this is 1/2 inch thick, obviously for rigidity and strength. So we do include 4 20mm long M4 screws, and they are M4 screws because from my experience, the vast majority of the routers, these trim routers on the market, use M4 screws, M4 threading to actually use for their router mounts. So generally these will be fine to mount your router to the router base plate, and they are long enough to go through the 1/2 inch material plus, you know, roughly 1/8 to 1/4 inch into your router. Now, if these screws will not work with your router, you can just go to the local hardware store, Home Depot, or wherever to get longer, more appropriate screws. You may have to countersink these holes depending what screws you get, but generally you're going to be safe by using these 20mm screws. So I'm going to go ahead and find the D, because D on our router plate represents DeWalt. Very creative, right? So just rotate your router plate along until all the D's line up with your holes, which is there. All right, I'm going to go ahead and put all of our screws into the router. Now, if you have a router that is not listed on our compatibility sheet, you can definitely still use it with this plate. All it means is that you have to pre-drill your own holes. So first thing you want to do is obviously see if it will fit any of these existing holes from other manufacturers, because a lot of the times they use the same router base alignments. If it doesn't, no big deal. Line up your router, mark your own holes with a magic marker, and then just drill the holes carefully, starting from an 1/8 inch router bit all the way up to 3/16 inch, which is generally enough to get these screws through. If you need some clarification on that, or you want to actually see me do that with one of our other router base plates, just search blank router base on the Crafted Elements YouTube channel, and that will show you how I align the routers to the router base and drill them. So I've got our router mounted, we've got our bearings mounted. Now we can mount our phenolic handles. These are very, very cool handles, and they definitely make moving this thing back and forth on those rails much easier. They are roughly 4 inches tall, and they've got a little bit of weight to them. So we're going to go ahead and just loosely fit them by inserting our 1/4 inch screws through that recessed, or rather countersunk hole, and then just tighten them up by hand. Now this section, or this part of the installation, is now complete. So we can go ahead and put that to the side. The next thing we're going to do is assemble our crossbar brackets. Now, you'll notice these crossbar brackets have the Crafted Elements engraving on it. In this case, the crossbar brackets top is where the engraving is. So with the router sled base, it's not the engraving part. The crossbar brackets have engraving on the top side. So we're going to go ahead and grab our open linear bearings. Now you'll notice with our crossbar brackets that one of the holes is offset, which doesn't make a lot of sense at first, but it will in a minute. So we've got the offset hole, and these are pre-tapped to with an M6 screw threading. So we're going to go ahead and line up our open topped linear bearings, and we're going to insert our screws the exact same way. We're going to use 20mm screws on the front here. So not the threaded part, not the offset part, but we're going to put our 20mm screws this way. And you'll notice I'm doing this with the Crafted Elements logo up and towards me instead of this way. And that's going to be kind of important. So we're going to go ahead and do that to this one as well. Again, 20mm screws on the bottom, not tightening them all the way because we want to run them down our rails to make sure everything's aligned before we fully tighten those guys up. All right, now we're going to go ahead and get our shaft end mounts. Now these shaft end mounts, you'll notice, have an adjustable Allen key hole there. So we want to keep these ideally on the outside rather than the inside. If you have them on the inside, it's just a little harder to tighten them if you need to adjust the tension. So we generally have them pointing out. And you'll notice now why that hole is offset. The offset hole will accommodate the offset hole on the mount, and then the one that's lining up will accommodate the hole here. Now this is also where the longer screws, those 30mm screws, come in, because you need the longer screws to go through the mount, the acrylic, and into the router, linear bearing rather. So we're going to go ahead and take the longer screw, put it there. We're going to take our hex screw, point it outwards, grab one of our longer screws, and go to the outside, which is not the offset hole. So again, on the outside, long screw, and here on the outside, long screw. And that will take care of the long screws included in the kit. And then you'll notice you've got 4 screws left, or should have 4 screws left. And that is where this threaded part comes in on the acrylic base. So we're going to use 4 short screws to attach the balance of this mount to our acrylic base. So now we're going to take our sub-assembled crossbar brackets and slide them on to our rails to make sure everything is nice and smooth. Now, if you do have some tension on these things, or you can't get it to go on there, then you might want to loosen up the clamps or the feet inside these bearings. You'll notice on the side of each of these bearings is an Allen key screw, and that will effectively reduce or increase the tightness or the grip on your rails. Now, the one thing I want to mention that's applicable to our larger router sled as well is that the bearings we use are anti-dust bearings. So we use them for obvious reasons, is that you're going to be creating a lot of dust with this system, and we don't want them clogging up the little tiny ball bearings inside these main linear bearings. Now, the disadvantage is that they create tension because you've got this rubber seal on each side of the bearing, and that rubber is literally gripping this side rail as hard as it can to create a tight seal. So you'll notice that I don't get a lot of motion without a little bit of effort. So it is completely up to you. You can easily remove these rubber seals with a standard screwdriver, take the rubber off and save them for a rainy day if you want to use them in the future. But that will make this slide much easier. I prefer to keep the rubber seals on there because I would rather be not cleaning out the bearings and blowing them out and oiling them and greasing them when they get kind of full of gunk. So it's up to you. Keep the rubber on, but you'll know that you'll be experiencing more effort when you move this thing yourself back and forth. Take the rubber seals off and you'll have a more fluid motion, but you'll just have to be cleaning the bearings every once in a while, and you'll risk, of course, clogging them during a job. So again, I've got that mounted. I've got this mounted, and you'll note that the mounts, or these shaft mounts, are on the inside. So these are on this side, not the outside. So when I'm looking down at these crossbar mounts, I can read the Crafted Elements logo. It's not upside down. So that's a little tight. I'm going to take this and reach over and loosen the Allen key screw in here. And now that I've got our sub-assembly on our rails, I can go ahead and tighten these screws up because I know everything's kind of kosher. Now, we are almost at the end here. We're going to go ahead and grab our rudder plate assembly and install our shafts through it. Directly into there and into the first mounts, pushing them all the way through so we can get to this side as well. All right, and now I can bring this over here and slide them back into this side. You'll also notice that these mounts have their own Allen key screw on them. So if you're having an issue getting the bars through the mounts, loosen up the screw first, and then once you've got it all set, we're going to tighten those screws all up. Now you're going to want to pull these bars to be lined up with the exterior of these rails. So essentially these are 32-inch bars. It's 32 inches to the outside. So you're going to want to have these bars overhanging roughly 1.5 inches. And it's important to have them exceed or protrude, because that's going to prevent them from flexing once we tighten up these mounts. So go ahead and line those guys up. It's pretty close. And then grab your Allen key and tighten the top Allen screw on the actual mounts. And you'll note why I said to keep these on the outside, because it's just a little bit more difficult to work around the inside. Doesn't affect the function, it's not backwards, just easier to tighten and loosen. And the one thing you'll also get in the kit, as mentioned, are these C-stops. So what these are for is creating an actual barrier to stop on your rails, because if you keep pushing, eventually it's going to come off, right? So these stops you can put in place with the Allen key screws on the outside and tighten them on the exterior of the rails. They do take a little bit of finagling to get on here because they are under tension, so you might want to just grab a mallet or a hammer to get them onto your rail initially. And I will say that these C-stops are completely optional to install. If you can control yourself from running your router right off the table, it's easier, because if you have these C-stops in place and you want to take your router carriage off to store it somewhere else, like for example, if you've mounted your rails permanently to your workbench, but you want to be able to move your router, the actual sub-carriage of this router sled, it can't come off without taking a side of these C-stops off, right? So I usually do not keep them on, but again, it depends on your own use case. And with our assembly now complete, we can install the router bit into our router. As I mentioned before, you're going to want to get a 1/4 inch shaft router bit, because that's generally what's going to be compatible with most trim routers, because they can only accommodate 1/4 inch router bits, and anything from 1 inch to 1.5 inches in diameter in terms of a spoil board or slab leveling bit. You do not want to get too big, 1 3/4, 2 inch, 2.5 inch. It's just going to put too much strain on a relatively underpowered router, because these things are generally only a horsepower. Whereas the big routers, like Triton TRA that I have, is 3 horsepower, 3 1/4 horsepower. Not a problem moving a 2.5 inch bit off against a large slab. So again, 1 inch to 1.5 inches is kind of the sweet spot for these spoil board bits with the trim router setup. And depending on the diameter of the router bit that you buy, you can either install it from underneath and kind of finagle it down here, tightening it up, or you can just remove your router directly from the actual base. Generally, most routers can pop out this way, and that way it's a little bit easier to get it in there and tighten it up. Now, when you're placing this thing in, you have to kind of weigh flexibility to safety. If you put it all the way down, you're going to have not as much flexibility to do skinnier or thinner slabs. All the way out, you could have a little bit more flexibility, but you risk the router bit running off or just being structurally unstable and spinning around. So generally, I like to keep a 1/4 inch to 1/2 inch of the shaft visible, and then I'm going to tighten this thing up with our wrench. It comes with your router. And then place it back in the carriage here. All right, and I'm going to unlock this, and I'm going to raise it to its maximum height. All right, so it's pretty much lined up with the bottom of the screws that hold our bearings in place. We can just get a quick measurement of that, or at least an estimate, and we have literally 2 inches dead on. So you've got 2 inches between the flat top and the bottom of the base, which means, or the bottom of your bit, which means that you can do a 2 inch thick piece of wood or slab. Now you might be asking yourself, well, that's great, you can do up to 2 inches thick with this setup, but what if I have a 2.5 inch or 3 inch or whatever it is thickness board that you want to plane down? Well, there's an easy solution to that, and that is when you mount your rails, to mount them on risers. These are literally 3/4 inch thick pieces of plywood, 2 inches wide and equal to the length of the risers. And before you install your rails on your table, or in this case our little top that we've made, you put your riser down first and then mount your rail through the riser. Okay, so if you visualize that, it's going to look like this thing is 3/4 inches off the surface of this. If you want to make it even higher, cut 4 of them and stack 2 on each side to have 1.5 inches. So essentially that will give you that extra height. So as it stands right now, I have 2 inches of available thickness that I can do. But if I added a 3/4 inch riser underneath the rails, I'd have 2 3/4. If I had 2 of these risers underneath each rail, I'd add 1.5 inches, or roughly have 3.5 inches. So then you might be saying, okay, Sean, that's great. I now have it raised up, but what if I want to do thin stock and my router bit can't reach all the way down because I've raised up my rails? Well, there's a solution for that too, and it is called a spoil board. So essentially just a narrower piece of plywood or stacked piece of plywood that you'll insert between the rails to raise your project up. And this is actually the method I prefer. I prefer having these rails a little bit taller and then using the spoil board, because once we get to this section of the video, you'll understand, but how do you mount your boards or your wood or whatever to this to keep them straight? You're generally going to be using something that's screwing down or clamping to your worktop. So having a spoil board, i.e. a board that can be spoiled, is really great, because you can make a mess of it, drill into it, and then replace it when it gets worn down and do something else. So there's a lot of flexibility in terms of the thickness of stock or table or charcuterie board or whatever you're making with this here. The one thing that we do recommend with our larger sleds is to use a collet extension, but I actually do not recommend using that with this trim sled. As soon as you get a high rotational speed and a long rudder bit, especially with that 1/4 inch shaft, there's going to be a lot of shear force on that shaft, and the longer that shaft gets, the harder it's going to be on your rudder and the bit. So I definitely recommend not using a collet extension with the trim routers. I would use a collet extension with the larger routers that's 1/2 inch in diameter. Instead, I would recommend either raising your rails with plywood risers, or doing a combination of raising your rails with plywood risers and using a spoil board in the case of thin stock. Now, the simplest way to keep your spoil board from moving is, of course, to mount it to your table or your frame. And in this case, literally 4 screws, 1 on each corner, is going to be sufficient for doing that. MDF is a great spoil board material, and it's often used in CNC machines because it is very, very flat from a factory. It is basically just compressed sawdust, glue, and wood fibers mushed into one to make it all nice and flat, but it makes perfect spoil board material, and it's relatively inexpensive. You can get it in 1/2 inch, 3/4 inch, and even up to 1 inch. So I've got some 3/4 inch stuff. It's now attached to our router sled base. It's now quite a heavy setup, so you might not even have to affix this to your table or clamp it down. We're going to give it a try without that. I'm going to go grab one of our wood and resin serving boards that I had made earlier in the week, and then we're going to mount this to our tabletop, which brings us to the next section of the video, is mounting or workpiece holding. So what I have here with me is my 3 favorite hold down methods. When you're using these slab levelers, doesn't matter if you're using the small router sled or the large one, generally it's the same. You've got the magic hot glue method, and it simply involves putting a goop of hot glue on every corner and making sure that it's well adhered. The last thing you want is your piece to move around while you're leveling it with your router. The next method would just be to use these little squares, and you can get these on Amazon for relatively cheap. They're aluminum and they've got holes in them. And if you have a rectangular piece, these are really handy, because you can just line them up here, grab your drill, and then put down some screws into your spoil board, which is again meant to be spoiled, and that thing is not going anywhere. If you don't want to buy these things, you don't have access to them, that's fine. A similar method would also just be to use some scrap wood and put it in the on the edges of your piece in such a way that it's opposing the direction of your router, which means that if you're moving your router this way, your piece is going to be moving this way. Then put these this way. Put them so the actual board's not going to move back and forth. If you're moving your router this way and you've got these on the edges, well, that's not really going to hold that in place, is it, right? So again, there's no general rule. If you can mount it securely and it's not going to move, then it works, then it's fine, right? And that's one of the good things, again, about the spoil board is eventually when you do a lot of projects with these, this board's going to look really, really bad. But you just toss it and get a new one, or flip it over and do it again, right? So what I'm going to do is I'm just going to use this method right now. I'm going to take these because I do have a rectangular board, which means it's really easy to use these squares to keep it in place. It's time for the magic. I'm going to go ahead and plug in my router so you can see this thing actually in operation. What we're going to do is we're going to take off at most a 1/16 of an inch, maybe up to an 1/8 inch, depending on the material at a time. If you've got resin and hardwood, you want to take off less. If you've got a softwood, cedar, pine, spruce, whatever, you can take off more. The premise is it's a lot higher density when you're working with resin and hardwoods than softwoods. So you're going to have more of a load on your router with the higher density materials, whether it be resin, wood, or resin or hardwood versus softer materials like cedar, pine, spruce, etc. So we're going to go ahead and just kind of set this to our height of our board right now. So we're going to go ahead and find out where the highest point of our board is just by loosening it until it kind of gets stuck. All right, so that's that point. So I can actually start there. If this is the highest point, this is lower, we're going to just start and slowly do this. This is not a one pass deal when you're using these router sleds. This is a bit of a process and it definitely makes a mess. So wear a mask, wear your eye protection and ear protection if you need to. When you're leveling these things because you have a lot of dust and make a lot of mess. Our larger router sleds have the option for a dust collection, but we did not design that into the smaller router sleds simply because of the real estate that would take up. So I'm going to go ahead, I'm going to get my safety protection on, and we're going to start leveling this thing. Now, there's different schools of thought in terms of which way you go. Small projects, I'm not sure if it really matters, but generally you want to go with the grain. So moving it this way is what you want to do. Now, when you're moving this thing back and forth, keep in mind that the router bit in there, I believe, is 1.5 inches or 1.25 inches. So you're going to want to just overlap it a little bit, right? You don't want to get right on the edge, like you don't want to go 1.5 inches if it's 1.5 inches bit. You might want to do an inch pass, then go another inch, and then do another pass, because each time you want to repass a little bit of the previous pass, if that makes any sense. So you can see that first pass we did, that initial pass, leveled off the highest part of the board, which is a little bit here and here. We can now increase the length of that bit by roughly 1/16 of an inch by unlocking it and moving our router down just a little bit to start getting a little bit more material off. Now, a couple of quick tips here. When you're pushing this back and forth, you do not want to apply any downward pressure. If you apply downward pressure on this router like you typically would when you were doing, say, an edge trimming job, you're going to end up having the potential to bow these things. Yes, they are 20 mil, and yes, they're only 32 inches long, but if you put enough pressure with the heavy router and your full body weight, you can definitely have deflection in these rails. So that's really the point of these handles. You can either push and pull this way, push and pull this way. Just don't apply downward pressure. That is one very important tip. The next thing is when you're doing epoxy. Epoxy tear out is infamous, whether you're using a CNC, a planer, router sled, whatever. So the slower you go on the epoxy sections, the better your finish is going to be. If I run through this epoxy really, really quickly, I'm going to end up with a lot of chipping and tear out. Not the end of the world. I can apply a clear flood coat of epoxy and fill in all those gaps you wouldn't even notice. But if you can avoid the tear out, clearly you want to. All right, I'm going to go ahead and lower this down a little bit more. Well guys, that concludes the demonstration of the Crafted Elements small router sled kit. We went over the installation, the assembly, what all the components do, and of course how to use it. If you have any questions or comments, or you want to get your hands on your own small router sled kit from Crafted Elements, or one of our larger full-size router sled kits, head over to craftedelements.com and click on the router sleds section of our website. If you have any additional questions, comments, or anything pertaining to this specific video, you can definitely leave them in the comments below here on YouTube. At the end of this video, I'm going to show you how to build this router base that I have this router sled sitting on. If that's applicable to you, stay tuned for the next few minutes and you can learn how to do that. Otherwise, again, thanks for watching and happy making. See you soon. So as promised, in this part of the video, we're going to be looking at building the platform to put the mini router sled on. Now, if you're going to attach the router sled to your existing workbench and it's a flat level workbench, you don't need to worry about this. But if you do want to build an extra sort of platform that you can move around and kind of store in your shop, then this is probably the easiest way to do it. So because that mini router sled is 36 by 32, 36 long with the rails, 32 wide with the crossbars, I've cut a piece of 36 by 32 sanded pine. You could use MDF for this, you could use oak. The key is that you want to have the flattest plywood possible. You do not want to have plywood that is warped. You want it to be perfectly flat. It doesn't have to be perfectly level in terms of your workbench, because if you've got, you know, your workbench or your tabletop or your floor is like this, the rails are also going to be like that. So you're going to keep that imperfection level in terms of being level, but you want straight and flat. You do not want cupped or warped, so to speak, right? So even this piece of plywood, which is pretty darn flat, isn't perfectly flat. If I turn on this side, you can see there's a little bit of give in the middle. So what I'm going to do is I'm also going to take the rest of this plywood offcuts that I have, and I'm going to cut 2-inch strips on the table saw, and then I'm going to essentially frame up a base on the bottom. And what that's going to do is once I flatten this down and use my nailer or screw it down, it's going to effectively force the plywood flat, or at least as flat as humanly possible. You could cut them on a table saw and then just use them. You can cut them on the table saw and run them through the planer to make sure they're dead flat. But if you're using this, you may not have a planer in your shop, because this kind of takes the purpose of a larger planer. So again, if you want to just use your table saw for that, as long as you've got it accurate and you're going to keep all the strips the exact same height, fine to use a table saw. So I'm going to go to the table saw. I'm going to set 2 inches arbitrarily. It could be 1 inch, it could be 2 inches, it could be 3 inches. Doesn't matter. All we're doing is making sure that we have a flat level base to mount this on. But I'm just going to pick 2 inches because it sounds like a good even number. And we're going to go over, we're going to cut those strips, we're going to come back and we're going to staple them, or rather fix them onto this, and we'll have our platform built that we can now attach our router sled to. Now it's a 32-inch side of this that we're seeing some bowing on. So I just cut my strips to 32 inches so we can actually run our strips this way. Running them this way, if you've got cupping or bowing happening, isn't going to help you. So you want to mount the strips this way to make this flat. So what I'm going to do is I'm going to put these every 6 inches. You can do every 6 inches, every 4 inches, obviously, and plus the sides. So I'm just going to go quickly and measure out 6 inches. Now, however you want to adhere these is kind of up to you. You could screw them down and countersink them. You could nail them by hand. I've got a pneumatic nailer, so I'm going to go ahead and use that along with some wood glue. These are 2-inch 18-gauge pneumatic nails. Probably do 1.5 inches to 2 inches would be just fine for this application. I'm going to support this side under here so we don't have a funky angle. And I'm just going to start lining these up with my marks, and of course on the edges as well, and nailing them in place. Keeping this tight without any gaps is going to basically guarantee that we have no bowing on our main top platform here. So you notice what I'm doing is I'm tacking the edge on one side. So if I apply some weight here, we'll make sure that it's nice and flush underneath there. our level, kind of run it across there. I don't see any warping or gapping. So, we fixed our piece of plywood. We have a perfectly, in a relative sense, flat base, perfect enough flat base that we can mount our router sled to. But again, guys, if you don't want to actually build your own base like this, doesn't matter. You can mount that router sled to your existing workbench or tabletop or spare shop bench that you may have, or come up with your own sort of secure base. I just did this because I want to have a sample of how you guys can do this yourself, but also be able to move this entire structure with the router sled on it around the shop, or to put it in storage without having to take it apart and take it off my tabletop every time.